Hello there. So for today's presentation, we're going to have our simple review of limits for us to have a grasp of limits in few minutes. So this is to enable us to have a quick review of limits, just the basic of those. For this one, we're going to assume our function is f of x and our x is approaching number a. So our standard procedure will be to substitute a to our x. That will be this number that is found here. Okay, this one that we see here. If it's a real number already, after substituting a to our function, if what we get is a real number, that means we're good. That will be our value already for our limit. Okay, so ayun, that means we're happy about it. But if we get a 0 over 0 after we substitute a to our function, okay, that means we have to do some factoring or we need to rationalize, and sometimes both. Okay, so this is of indeterminate form and we don't have an indeterminate answer for our limit. Okay. Also, if it's a c, a non-zero constant over 0, non-zero constant over 0, that means our answer is either positive infinity or negative infinity. So ayun, we substitute a to our variable in the function. Normally it's x. If what we get is a real number, we stop and we're done. We're happy about it. Yay! Okay. But if what we get is 0 over 0, we do a factoring or we rationalize. Okay. And then if what we get is a non-zero constant over 0, we expect an answer to be positive infinity or negative infinity to be our value for our limit. Okay. So that's for our graphic organizer. Next example, say we have this. Ayan. So if we substitute 4 to our y, we get square root of 4, which is 2. 2 plus 3 is 5. Then we have here 8 minus 1. 8 minus 1 is a 7. Correct? So again, 5 over 7, though it's a fraction, still it's a real number. So 5 over 7 is the value for our limit. So we're happy again about this. Okay? Plain substitution. Now, what about in this limit? Ayan, so again, if we do an inspection by substituting 2 to our x, we have here a 4 minus 10 and then plus 6. Okay, tapos here we have 2 times 4, which is 8 minus 8. So what we get is a 0 over a 0. Okay, this is 0, this is 0. So it is of this form. Okay, take note that we can both factor the numerator and denominator. Okay, just happen that both of them are factorable. So that means we take this first option. So we do some factoring. Take note that the limit notation is still there. We haven't evaluated the limit. So we use the factored form. Take note that the clue here is, yan, take a look at this one. We just have to convert this arrowhead to a minus sign. So converting that to a minus sign gives us x minus 2. Okay, which means x minus 2 is the expected factor to cancel out. Okay, so we expect x minus 2 to be one of our factors both in the numerator and denominator. Okay, now if you see here that 6 is a constant, you can just divide this 6 by negative 2. 6 divided by negative 2 is negative 3. And then you just have to write the variable or the square root of x squared, which is x, and so you have your other factor already. Okay. Now for this one, notice that both 2 and 8 are divisible by 2, so you can factor 2. And then you can write x squared minus 4. Okay. This is a difference of perfect squares. So you have the 2 again. The square root of x squared is x. The square root of 4 is 2. So we have the x minus 2 and the other one is x plus 2. But then again, you can still consider 4, divide by -2, and you'll get +2. Okay? So as expected, the x minus 2 will cancel out. So what you have now is x minus 3 over 2, x plus 2. And as x approaches 2, we are now ready to substitute. We have 2 minus 3, which is -1. And then we have 2 times 2 plus 2, which is 4. And so our answer will become -1/8. This is the answer to the limit that's given on this slide. Oh. For our next example, we have a variable t this time. Okay. So, ayun. If we are to inspect, again, we substitute the 9 to our variable. This will give us 81 minus 72. We have a fairly large number here. Minus 9. Okay. And then we have, on the denominator, we have square root of 9, which is 3. And then a minus 3. Notice that again, for the numerator, we have 81 minus 81. That will be 0. And then denominator is obviously a 0. Okay. So what we do now is, this is of this form. Though the numerator is factorable, we make use of that. And at the same time, notice that we have a radical on the denominator. At the same time, we will have to rationalize. So ayun, we have these two things to consider. Okay. So for the limit, as t approaches 9, we factor the numerator, and at the same time, we do some rationalization later. But we do one at a time. So factoring muna. Again, the expected factor to cancel out. Change this to a minus symbol. We have t minus 9. Okay. So we have t minus 9. And then -9 divided by -9 is 1. So positive 1. T squared, square root of that is t. So that will be the other factor. Okay. You can double check by using your FOIL method to see if you arrive at the same given. Okay. Now you have square root of t minus 3 on the denominator. Okay. We enclose that in a parenthesis. Now to rationalize, remember we are to multiply by the so-called quote-unquote conjugate, no? So if that is a minus, this is a minus, we have to multiply with the plus version of that radical. So we have square root of t plus 3. Okay. The idea here is to get the sum and difference of two numbers so that we have a difference of two squares. Okay, so we do the same thing for the numerator. Yan, parang nag-multiply lang tayo by 1. This fraction, this blue fraction here is equivalent to 1. So again, the idea here is having a minus b times a plus b. And using our special products in algebra, this is just a squared minus b squared. Okay. The idea here is to get rid of the radical on the denominator. Okay. So what we have is limit as t approaches 9. Tapos what we have is t minus 9. Notice that we're leaving it in factored form because our objective is to cancel the t minus 9. Yung nagpapa 0 over 0 sa atin. And then, yung sa denominator, yun ang i-multiply natin using special product. So, RA is square root of t. So, if you square that, the radical will just disappear. Squaring the 3, that will be your b squared, diba? Yung a squared natin is t. Yung b squared naman natin is 3 squared, which is 9. So, minus 9. Ayan, lumabas na yung t minus 9. But then again, you have an extra factor here coming from this one. Okay. Ayan. So, sa denominator, we did the multiplication already. So, ito yung version na ginamit natin. Okay, this one. Now, we can cancel the t minus 9. And now, we are ready to substitute. This will be 10. 9 plus 1 is 10. And then, square root of 9 is 3. Plus 3, that will be 6. Multiplying 10 and 6, we get 60. And this is our value for the limit given in this slide. Okay, so now, next example. This time we have 9 plus 3 minus 12. 9 plus 3 minus 12, that will be here. That is 0. Tapos for the denominator, again, we have 9 minus 18 plus 9. And again, this is 0. So 0 over 0 yung form, which means we will factor or rationalize. But obviously, these are both factorable equations. So we write the factored versions here. Okay. Notice that we're coming from the left of 3. So again, we expect x minus 3 to cancel out. We change this to minus symbol. Okay. So x minus 3 is an expected factor. We have an x minus 3 here. Okay. Negative 12 divided by negative 3 is positive 4. Diba? Negative divided by negative is positive. Okay. And then positive 9 divided by negative 3 is negative 3. Yeah, so we can cancel the x minus 3. But if we substitute 3 to our equation, remaining equation, this is now 7. This is 0. Okay, so as you can see, it was of this form, 0 over 0. Now it is of this form, non-zero constant over 0. Okay, which means our answer is just either positive infinity or negative infinity. How do we know the sign of our infinity? Okay, so since this is already positive, the numerator is already positive. Okay, all we have to do is think of the sign of the denominator before it became 0. Okay, so here we're going now to consider the superscript. Okay, so kanina we were not minding this superscript here. So we're coming from the left of 3. So left of 3 daw. So we have a 2 here and then a 4 on the right. We want a number very close to 3 but nasa left niya. So we want somewhere here. Okay, so that will be 2.9, 2.99, 2.999. Nonetheless, this will be a number less than 3. If you subtract 3, that will be negative. Okay, so positive over negative, that means we have a negative infinity. Okay, so that enables us to determine the sign of our infinity. Okay, so that's how we get the answer to this. What about this one? Okay, if we substitute negative 4 to our x, we have a 16 there. Negative 4 times 2 is negative 8 minus 1. So that will be 16 minus 9, which is a 7. But for our denominator, we have negative 4 plus 4. And that is a 0. Okay. So again, it is of this form, non-zero constant over 0. Which means again, our answer is either positive or negative infinity. Okay. But then again, this is already a positive number. All we have to do is determine the sign of our denominator before it became a 0. Okay, so again, we take a look at this part. Okay, yan. We now focus our attention on the superscript. Okay, we're coming from the right of negative 4. Be careful with the negative sign because here we have a negative 5 and here we have a negative 3. Since we're coming from the right of negative 4, pero very near to negative 4, we want numbers that are somewhere here. Okay, so those numbers are negative what? Negative 3.99, negative 3.9999. Okay, so if you consider that here, negative 3.9 plus 4, the answer will be positive. Okay, so you have positive over positive, like signs, that means we have a positive infinity for this one. Okay, so this is the answer to our limit here that takes into consideration the behavior of this rational function as x approaches negative 4 from. Now let's see if we're given with this one. We're given with the limit of function f of x over g of x as x approaches positive or negative infinity. This time we can no longer do substitution kasi Diba? We're dealing now with a very, very large number or a very, very small number for the case of negative infinity. Okay? Though 1,000, 10,000 is fairly large enough, okay? Still, those are very, very small compared to positive infinity. Okay? So we have these three cases. First one is having these two polynomials. So we're considering polynomial functions here, rational functions, wherein f of x and g of x are polynomials of the same degree. Okay? So let's change the color of our pen. Okay? So same degree means the highest exponent for the numerator and the highest exponent for the denominator are just the same. Okay? Just like in here, both have a degree equal to 3. Okay? So for that example, if that is the case, all we have to do is simply consider the coefficients of our variable, regardless whether our x is approaching positive or negative infinity. Okay? So answer here will just be 5 for the numerator, 10 for the denominator, and then we just do a necessary simplification whenever needed. So this one is 1/2. This is the answer to the limit that's given in here. Okay. Now for the second case, what we're given is like this. The degree of the denominator is greater than the degree of the numerator. Okay, so regardless again whether our x is approaching positive or negative infinity, the answer to this limit is a 0. Okay, so that's it. This is already the limit and we're happy about it. It's the very easy case. It's the easiest one, I think. Okay, ayan. So for the last case, if the degree of the numerator is greater than the degree of the denominator, just like in here, this is 13. Whereas yung denominator natin has a degree 3. The shortcut here is to just consider those leading terms for your numerator and denominator, respectively. Now, the sign of infinity will matter, okay? So, if you simplify, you have 5x to the 13 over 10x cubed, okay? This will give us, yan, for using the law of exponent for this part, we have x to the 10 over 2, or simply 1/2 x to the 10. Yan. So regardless whether our x this time is positive or negative infinity, since we're dealing with an even exponent for our variable, this will yield a positive infinity. Okay? So positive infinity, even you divide it by 2, still is a positive infinity. Still is a very, very large number. Okay? So the answer here is positive infinity. Okay? So the moral of the story, same degree, just deal with the coefficients. Degree of the denominator greater than the degree of the numerator, limit is 0. Degree of the numerator higher than the degree of the denominator, answer will be positive infinity or negative infinity depending on the simplified version and depending on what x or what is the sign of infinity the x is approaching to. The next example, say we're given with this function as x approaches negative infinity. Again, all we have to do is consider the exponent. This is the third case. So we just have to consider the leading terms again. Okay. This is a bit similar to the previous one except that I made this exponent on the numerator equal to 12. Kanina it was 13. No? So this time we're given with 5 over 10 x to the 12 over 12 tapos 3, diba? Using the laws of exponent, 12 minus 3 is 9. Okay? So we are given with the limit as x approaches negative infinity. This is again 1/2. Okay? This time, the sign of the infinity will matter kasi we are given with an odd exponent. Okay? Raising a negative number to an odd exponent gives us a negative number. Okay? So even if you divide it by 2, still it's a negative number that is very, very large in value. Okay, but different, but negative in sign. Okay, so negative infinity is our answer. Kasi odd, tapos negative infinity. Okay, so difference with this example. So we are given with this one. This time our exponent is 10. Okay, so again we have 5 over 10. We make use of the leading terms. 5 over 10. Tapos x to the 10 minus 3, which is 7. Limit as x approaches negative infinity. So again, this is 1/2. Tapos x to the 7 is a variable with an odd exponent. So the sign of the infinity will matter. This will still be negative. Okay, naka-raise sa odd exponent. So negative infinity is our answer here. Okay, we're asked if this happened to be, say, 11. So say if we're given, for example, with the limit as x approaches negative infinity, let's change the value of the given. So say we have 2x to the 11 minus 5. Tapos for the denominator, say we're given with 3x cubed minus 4. Okay? So sabi natin, we just have to consider the leading terms. That would be 2/3 x to the 8th. Okay? So this is an even exponent rather. Even exponent. So though you're approaching negative infinity, this box expression will be positive already. Positive infinity. So with the positive coefficient there, this will be positive infinity. Okay. Now what about if we are given with, say, limit of negative 5x to the 17, say plus 1, all over 2x cubed minus 4, yan, as x approaches, say, negative infinity or positive infinity. Actually, it will not matter much kasi look at the exponent. So, yan. You have x to the 17 minus 3. That will be x to the 14. Even exponent. So, negative and positive won't matter, no? Pag even yung exponent, negative or positive infinity won't matter. But since you have a negative 5/2 for your coefficient, supposedly this is positive already. But with the negative multiplier, the answer becomes a negative infinity. Yan. So that's how you play with the infinity. Okay? So positive, negative, positive infinity, multiplying it by a negative coefficient results to a negative infinity already. We can try it with, kunwari, positive 1 billion times negative 5/2. It will automatically a very big number pero negative in value. Okay? So that's it. That will be limits in a nutshell. So I hope that helps for your understanding of limits. Thank you so much for listening.